How are you doing today? So today's lecture series is going to be about our chemical world. So what is the chemicals in our world? Most people think about it as being things like pollution or medicine, but what chemicals are is pretty much everything you come in contact with throughout your entire life. It's a way that we're going to better understand our life and our world here in chemistry this year. So let's see if I can get that going. There we go. So let's just take a look about one of these phenomenons that we all come in contact with all the time. So soda, something I don't really drink, but my kids love it. So what makes soda fizz? Well, what's in the soda that makes it fizz? Well, soda has some stuff in there, and that stuff is called, carbon dioxide. So there's carbon dioxide inside that soda. So what is carbon dioxide? Well, carbon dioxide is a chemical, and when we open that carbon dioxide, or when we open up that soda, the carbon dioxide comes out, and that carbon dioxide is a gas. So in order for that carbon dioxide to gas to escape, you have to open up the soda, and all of a sudden something happens which we've never seen before. So So why does soda make that psst sound? Well, that psst sound is due to the carbon dioxide gas. So when you feel carbon dioxide, when you open up the drink, do you feel the carbon dioxide that's inside? Absolutely you do. You feel it on your tongue, you feel it in your mouth, you can feel it kind of sizzling, kind of like those little pop rocks that you would eat when you were a kid, and you'd put them in your mouth and you just feel this, popping sensation. So soda is also very sweet, and soda is very sweet due to all the sugars and everything that's inside of the beverage, which again are chemicals. So chemistry will affect everything that's in your life, whether you notice things or whether you don't notice things. Everything we eat, everything we drink, all of those things are chemicals. So chemicals make up almost every single thing in the world. Everything we come into contact with on a daily basis, the air we breathe, the cars we drive, the food we eat, sodas, textbooks, even your own body. Even your own body is made up of chemicals. Chemists are interested in the matter, and the matter is what makes up everything in the universe. So what is matter? Not what is the matter. Question is, what is matter? Well, matter is anything that has mass. And what is mass? Mass is kind of like weight. It's not weight, right? Mass is stuff. So anything that has mass is matter. Matter also takes up space. What is space? Space also is known as volume. Now, we measure volume in a couple different units. The unit that we use in America for volume is we use the gallon, which is kind of an interesting unit, only being used in America. If you think about things that are measured in gallons, it's usually stuff that we don't sell to other countries. Things like milk. Things that we do sell to other countries come in what's called a liter. Stuff we weigh over here, those comes in America. We usually weigh things in pounds. But other countries and the rest of the world use grams. That's what mass and volume is. So matter is anything that takes up space and anything that has mass. Some examples of that are solids, liquids, and gases. So a car, for example, is a solid. We drive it around, we can hold it, we can grab it in our hand. Liquids are also matter. The molecules, which we're going to go talk about when we talk about solids. So when we're talking about this car, we are talking about solids where molecules, well, we haven't talked about it, but where atoms and molecules are really close together. Liquids is when we have molecules that are slightly close together. And then our last one, yes, when you do a pedito, or when you do a little fart, yes, those gases are, that gas that comes out is a gas, real life gas chemical, which we will work on in chemistry class. So matter are solids, liquids, and gases. So what is matter? Again, matter is anything that takes up space. Well, anything that is, there must be something that's an opposite. So non-matter is the opposite of matter. Matter is anything that does not have space, does not have mass. And you think, what are some things that don't have of mass? If something exists, it must be matter. Well, things that are examples of non-matter would be things like energy. Okay, energy is a non-matter, and any kind of abstract concept is non-matter. So what are some things that are energy? Well, the fire that you feel, the energy coming off, that is not matter. All that is heated up gas molecules which have gained this energy, which is non-matter. Things that are abstract that are non-matter would be something like the flag, but not the flag per se, but what the flag stands for. So if you think about the flag, you think the flag represents something. Well, the flag, that is physical. But the idea of the flag, what it represents, oops, freedom. I write like a third grader. Maybe not even that good, all right? So freedom, ladies and gentlemen. So freedom would be an abstract concept that's just kind of up in the mind somewhere, an idea, and an idea is an abstract concept. Something else that's an abstract concept would be time. Time means what? What is time? Can I grab onto time? Does time have substance? No. A clock is matter. But time, the actual idea of time, is abstract and it's non-matter. So that brings us into atoms. So, oops, I put that out of order. All matter is made up of tiny particles called atoms. And those tiny particles are really small. So an atom is a word you've probably heard before. An atom is, an atom is matter. An atom takes up space. An atom has mass. An atom is an actual particle. So you've heard this term before, atoms. And atoms are so small that in a single drop of water, you have about 1 billion trillion of those atoms. So how small is 1 billion trillion? Well, pretty small. I mean, if I had that much money, I don't even think there's that much money on the planet. That is one huge, huge number. If you took all the money on the planet, there's not that much. So it's a huge number. There's not that many people, probably that many insects, but there's not much that there's 1 billion trillion of. So molecules, ladies and gentlemen, sometimes get confused with an atom. So molecules get confused with atoms, and we don't want to confuse those words. So a molecule is actually made up of atoms. So some examples that people have come up with before is that molecules are the actual substance, but they're made up of atoms. So let's just imagine Legos, right? You have a bunch of different Lego blocks. We can represent these and say, well, each one of these Lego blocks would be an atom. But if we took these Lego blocks and we actually made something with the Lego blocks, we made a pyramid, well, this all of a sudden becomes a molecule because the molecule is made up of the individual atoms. Another example of molecules and atoms, so you can kind of see the difference, is maybe a car. So a car has tires. Let's draw 4 tires. And the car has a car body. And we could say that each one of these are different atoms. Those are wheel atoms. That's the body of the car atoms. And so these atoms, when we put them together and make a car, we could say that this car, that is the most beautiful car ever, you guys. You are lucky to have me as a teacher. That car, ladies and gentlemen, would be the molecule, whereas the individual pieces would be the atoms. And that's where we say right here, atoms combine together to form molecules. Well, these down here are molecules. And you can see that this molecule is made up of a carbon and 2 oxygens. Oxygen on that side, there's an oxygen on this side, but together, these make a carbon dioxide molecule. And carbon dioxide is the gas that we breathe out of our mouth, and you've probably heard that word before, but maybe you didn't realize that it was carbon dioxide, and that's where it comes from, carbon dioxide. Another molecule would be water. Water is made up of, this would be water right here, H2O means water. So water is made up of an oxygen atom, and it's made up of 2 hydrogen atoms. So those 2 hydrogen atoms, when they combine with the oxygen, become water. So this whole thing is a water molecule. All right, so chemicals are anything that you can hold or touch, right? Chemicals, sorry. So anything that you can hold or touch would be made up of chemicals, ladies and gentlemen. There are lots of different chemicals, and we just went through some of them. Some of them we just said were, you can take a look. So what would be a chemical? CO2 is a chemical. H2O is a chemical. Methane, that's stuff that comes out when you do a fart or a pedito. And then anything else. I think we talked about sugar, C6, H12, O6. All of those are chemicals. They all are matter. They have space and they have mass. Some other examples would be toothpaste, Tylenol, soda, toilet paper. All of those are made up of chemicals. And chemicals are just a simple name for all the different molecules that exist. So anything that exists that's not just an individual atom, but anything that comes together, be the plastic in this pin, right? Or the cotton that makes up this little bag, all of these things are made up of molecules. So the next thing that we're going to take a look at is, well, what exactly is chemistry? Well, chemistry, which has the word chemicals in it, chemistry is made up of matter. Chemistry is the study of matter. And chemistry is made up of all the chemicals. But chemistry is the study of how all those chemicals interact with each other. All those molecules, all that matter. It's the interactions of the chemicals. That's what chemistry is. Studying how things can get made, what happens when different things, that when you mix sugar with water, right? There's reactions going on. So let's say that we have iron, metals. Everything that you see around you that's a metal, those are elements, and those are chemicals. Many times the metals you see aren't just metals. They're they're amalgams, or they're mixtures of different types of metals that are put together. Chemistry is also working with this coronavirus that we've been so in tune with for the last months. If we want to fight this coronavirus, we have to work with chemicals. We're going to have to work with enzymes, right? Proteins, all this stuff you heard in your biology class, all of this stuff, the vaccine that we're going to make, all of those are going to be chemicals that are going to be put together. And it's going to take chemistry to put all that together. A nuclear bomb or some type of huge explosion, that is a chemical reaction. And just something as simple as cleaning your toilet, which the chemicals they use to clean the toilet, we'll be working with those this year. Not in the same form as the toilet bowl cleaner, but we'll be working with those, because mainly that is just very expensive bleach, but we'll talk about how the chemical industry rips people off. So that's what chemistry is. So what do we have? Well, next, what you're going to do is you're going to complete the assignment for the day. This is going to be assignment number 4. So this is day number 4. And you're going to read the instructions and you're going to turn that in on Canvas. I will be here with you the entire time. So if you have any questions, please check in. If you're struggling, you're like, oh, what was Mr. Pepe talking about? Go back and rewind that video a little bit. While you're doing your activity, if you need information from the video, go and just rewind the video a little bit and you're all set. But again, I'm going to be sitting right here with you. So come and check in with me whenever you need me. Okay, good luck. I hope you have a great day.